right, so today we're going to talk about solving exponential equations. So we have to change a base formula. Logs with any base can be written in terms of common logs another base or natural logs. So if we have the log base b of a, we can rewrite this using base 10 as the log of a divided by the log of b, and the base would be 10 here. And we can rewrite this as the log of some other base we'll call p of a over the log of that same base p of b. And we can also write this as the natural log of a over the natural log of b. That would, of course, be using a base of e. So just to look at these first examples that we have right here, we have the log base 6 of 11, so we can write this as the log of 11 divided by the log of 6, and then in your calculator, the log button is next to the 7, so you just hit that. So you do log of 11, make sure to close the parentheses, divided by the log of 6, close parentheses. And of course, don't forget we're rounding using 3 decimal places, but it doesn't hurt to round to 4. So I'm going to go ahead and write this as 1.338, and then that would round to 3. So we need at least 3 decimals. And if we did the natural log of 11 over the natural log of 6, the natural log is right below the log button. So the natural log of 11 divided by the natural log of 6. Make sure to close those parentheses. Notice you get the same thing. And so we could also pick any other base. So looking at the next one, we have the log base 4 of 32. So this would be in base 10, the log of 32 divided by the log of 4. So in your calculator, log 32 divided by the log of 4. So that is equal to 5 halves or 2.5. So if I were to also do the log base 2 of 32 divided by the log base 2 of 4, that would also give me 5 halves. And remember, we do have that log base button in our calculator. If you go to math and then scroll all the way down to A, log base, enter. So we have the log base 2 of 32 and divide that by, and then go to math, log base 2 of 4. Notice that we get our answer to be the same. The only thing is that it takes longer to do the math log base button and then plug it in. So it's a lot easier just to use log or natural log, which is what we normally use. But again, you can go ahead and change that base. Let's say we did a 5 for the base here and change this to 5. Again, notice it gives you the same thing. So it doesn't matter what you use. It's just usually easier to use that base 10 or natural log because we have a button for it in the calculator. So looking at question number 3, for this one, we can write this as the log base 3 of 24 over 11 divided by the log of, we're base 3, log base 10 of 24 over 11 divided by the log of 3. So in our calculator, log of 24 divided by 11 and divide that by the log of 3. So that gives us about 0.7101. We could also use the properties of logarithms to solve this. This would also be the log base 3 of 24 and then minus the log base 3 of 11, because if you have the arguments that is a quotient, you expand the logarithms using subtraction, and then you could use the log of 24 divided by the log of 3 minus the log of 11 over the log of 3 or natural log or whatever base you want to use. And if you did that, you would still get the answer 0.7101. It's just a little bit more work, but they all work. So exponential equations. Exponential equations is an equation in which the variable is in the exponent. All right, sorry, I just moved that over. So an equation in which the variable is in the exponent, always check for extraneous solutions. So it's always good just to check to make sure whatever your answer is that it works when you plug it back into the original problem. So we're going to solve by equating the exponents, which we did this in Math 1, and we also did Math 3. Now we're doing it in, of course, AP Pre-Cal. So for this one here, we have the same base already. So if the bases are already the same, then it's nice because you can just drop the bases and set the exponents equal. So 2x plus 3 is equal to 4x minus 5. And then, of course, you're just solving for x. So subtract the 2x, we get 3 is equal to 2x minus 5. Add the 5, we get 8 is equal to 2x. Divide by 2. And, oh, sorry, hold on. Yes, divide by 2 and x is equal to 4. So if I want to check, I would do in my calculator 5 to the power of 2 times 4 plus 3, enter, and then that should be equal to 5 to the power of 4 times 4, and then minus 5. So those give me the same values, so that checks out. So then for the next one, we don't have the same base, so now we have to get the bases to be the same. Whenever you're trying to get the base the same, you need to be careful because you want to make sure whatever you're replacing the base with is equal to that number so it doesn't change the equation. So in this case, I would notice that 81 and 3 both have a common base of 3. So I'm going to try to make these both into the 3. I don't ever want to try to make the 1/3 into the larger number. If you make the 1/3 into the larger number, then you're changing the actual equation. So we know 3 to the 4th is equal to 81. So because those are equal, by replacing that in my equation, it doesn't change the equation. And then I know that I can rewrite 1/3. I can rewrite this as 3 to the negative 1 power, and that is equal to 1/3. So 3 to the negative 1 doesn't change my equation. And then we have 5x minus 6. So here you want to do the power rule. So this would be 12 minus 4x is equal to power rule here, 3 to the negative 5x plus 6. And then you're going to drop those bases and set the exponents equal now. So 12 minus 4x is equal to negative 5x plus 6. And then we're going to go ahead and solve. So if I add the 4x, we get 12 is equal to negative x plus 6 minus the 6, we get 6 is equal to negative x. So therefore, x would be equal to 6. So then again, for this, if we check, we have 81 to the power of 3 minus 6, and that should be equal to 1 divided by 3 to the power of 5 times 6 minus 6. Oh, that's not equal, is it? Where did we go wrong here? So add the, oh, I see. I forgot the divided by the negative. So x is equal to negative 6. So sorry about that. So then when we plug in this negative 6, so let's try that again. 81 to the power of 3 minus negative 6, and then 1/3 to the power of 5 times negative 6, and then minus 6, and there we go. So that's another reason why it's always good to check your final answer, just to make sure that you're not missing any values. All right, looking at the next one. So solve by rewriting in logarithmic notation. Find both the exact and approximate solution. So you need to be able to do that on your AP exam. So when you are doing this is when you have an exponent is only on one side of the equation, or if you cannot rewrite the equation using the same base. So if you look at question number 6 here for this problem, I would see that I have exponents only on one side. So if that is the case, then always make sure to isolate. So I guess I should write this if you have the top one, let's put it up here. So always isolate the exponential expression first. So what is the exponential expression? The exponential expression is the base with the exponent. So you always want to make sure that that is by itself on one side of the equal sign before you can rewrite this in logarithmic form. So right now I have 10 to this power, and we have it equals 625. So this would be rewritten as 10 is the base. So this would be in log form, log base 10. The argument of the log is going to be 625 is equal to the exponent 4x plus 1. Because remember, the answer to log is the exponent. So then when I'm solving this, I would subtract the 1, and then I get log base 10 of 625 minus 1 is equal to 4x. And then the last step would be to divide by that 4. So the exact answer is the log base 10, and you don't have to write base 10, so you can just write the log of 625 and then minus 1 over 4. Now be very careful because you cannot take that 625 minus the 1. The 625 is inside the log, and I often see students try to subtract those and write it like this, the log of 624 over 4. And then some students might try to divide that 624 by the 4. You cannot do that, so don't make that mistake. So if I'm going to now find the approximate solution, I'm going to plug this into my calculator using the log of 625. You have to close that parentheses, otherwise your calculator is going to subtract the 1 from what's inside the argument of the log, and then we're dividing that answer by 4. So we get x is approximately 0.4490. So if we want to check our answer, we have 10 to the power of 4 times, and so for this one, to get the exact answer, I'm going to use the answer that I have above here, and then plus 1, and notice that gives me about 625. It may not be equal to exactly 625 because of rounding error, so just kind of keep that in mind when you're doing these problems and checking your answer. You might have some rounding error from that, but that does give me my solution. All right, looking at the next one that we have. So for this next one, we have 7 to the x equals 5. So for this one, again, we're going to rewrite this using our log form because the exponential expression is already isolated. So this is the log base 2 of 5 is equal to x. So then the exact form would be log of 5 over the log of 2. We can write it in either one of those two ways. And then x is about equal to, so in your calculator, the log of 5 divided by the log of 2, or you can use that math change of base button. So 2.3219. Looking at the next one that we have right here. So for this problem, again, you need to isolate the exponential expression. And so that has to be done first. So that means we need to add the 5 to the other side. So 7 to the 9x is equal to 15. So then rewrite this in log form. Log base 7 of 15 equals 9x. And divide this by 9. So x is equal to log base 7 of 15 divided by 9. You can, of course, also use the change of base. So you could also rewrite this as the log of 15 divided by the log of 7 all divided by 9. That would also work. So in my calculator, if I go to the math log base button, we have the log base 7 of 15, enter, divide that by 9. And so x is about equal to 0.1546. All right, for these next problems, notice that we do have exponents on both sides of the equation. So since you have exponents on both sides of the equation, we can't make the bases the same. That means we're going to use log form. And so does it matter which one I choose, which side I choose to be the base? No, you can choose the 3 to be the base or the 2. For this one, it would be easier if you use the one that doesn't have the x plus 2 in it. So I'm going to choose to make 2 as the base for this problem. So this is going to be the base. So we're going to rewrite this in log form. So this would be the log base 2 of 3. Oh, you know what? Let's actually, it'd be easier to do the other one. Sorry. Okay. We're going to make 3 the base. You can do both ways, but I'll show you why it's easier on the next problem. So for this one, if we make the 3 the base, then this would be log base 3 of 2 to the negative x is equal to, and the exponent of the base is x plus 2. So this is equal to x plus 2. So then for this, when we're solving, we don't want to have those variable exponents. We can use our property, product property to bring that down in front. So negative x times the log base 3 of 2 is equal to x plus 2. And then notice you have x's on both sides. You want to combine your x's. So I'm going to subtract that x, or I could add this x. It doesn't really matter. I'm going to go ahead and subtract this. So I have negative x log base 3 of 2 minus x is equal to 2. And we're trying to solve for x. So if you have x in two terms, right here, you need to factor it out. Kind of like if I have, let's say, 2x plus 1x like this, what does this factor into? You would take the x out, and then that would become, maybe I should put another value here. So let's do xy. So if I take this x out, this becomes 2 plus y. It's the same idea with the log. So I'm just going to take out the x. So this would be x times negative log base 3 of 2 minus, and I still need that placeholder, 1 is equal to 2. Divide this, and you get x equals 2 over negative log base 3 of 2 minus 1. This would be the exact form, and of course you could write that log base 3 of 2 as the log of 2 over the log of 3 if you don't have the log base button in your calculator to use. So then for this one, let's go ahead and evaluate this. We have math log base, oops, actually this is 2 divided by, make sure you use parentheses around everything that's in the denominator. So then negative math log base, and if you don't have this button, you'd have to use a change of base formula, 3 of 2, and then minus 1, close those parentheses there. And so we get our answer to be about negative 1.2263. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . So that would be the exact answer and then the decimal approximation. And again, you can rewrite this other ways using the change of base formula or other properties, because like we could even rewrite this -1 as a log, right? So as a log, how do you rewrite that? Well, you have to think about, well, what's the base here? This is base 3. So we could do the log base 3 of 3. That's equal to 1. So you could say that that's minus the log base 3 of 3. So there's a lot of different ways you can rewrite this in exact form. Looking at question number 10, so again for this one, notice that you cannot make the bases the same. So we're going to pick one of the sides to make the base. So I'm going to go ahead and pick 5. So this would be log base 5 of 4 to the x plus 3 is equal to the exponent 2x minus 1. So on the other problem, could you have made base 2? Yes. And can I make this instead of base 4? Yes. But whenever you have an x plus something, just makes it a little bit longer. So you have to take this and, of course, bring it down in front, because that's the power property we're trying to solve for x. We don't want it as an exponent, especially inside the argument of log. So x plus 3 times the log base 5 of 4 is equal to 2x minus 1. Then the next step would be to distribute this log base 5 of 4. So this becomes x log base 5 of 4 plus 3 times the log base 5 of 4 is equal to 2x minus 1. And then right here, you'll notice that you have x's on both sides of the equation. So you want to get those to both one side and anything without an x to the other side. So I'm going to subtract the 2x to this x here. So x log base 5 of 4 minus 2x is equal to, and then I'm going to take this one right here to the other side by subtracting that. So on this side I have -1 minus 3 log base 5 of 4. Once you have the x's on one side, then just like the last problem where we could, do something like this and factor out the x to get by itself, that's what we're going to do. So we have x times the log base 5 of 4 minus 2 is equal to -1 minus 3 log base 5 of 4. Now that x is by itself, the last step is to divide, because notice the log base 5 of 4 minus 2 is being multiplied. So we just divide that out. So I get x is equal to -1 minus 3 log base 5 of 4 over log base 5 of 4 minus 2. And then you just have to plug it into your calculator. And again, there's other ways that you can rewrite this using the change of base formula, getting every number in as a log, but we're just going to leave it like this for now. So we have -1 minus 3 math log base 5 of 4. Make sure to close those parentheses for the numerator. And we're going to divide that by the math log base 5 of 4 of minus 2. And make sure to close all those parentheses, enter. So we get that this is about 3.1476 as our answer. And again, if you don't have that math log base button, you would have to use a change of base formula. All right, so looking at the last ones, you'll notice that all of these have a base e in them. So if it's a base e, you can use log base e, but we're going to use the natural log to practice. So we need to isolate the exponential expression first, which is the e to the 2x. So you're going to subtract the 5/2 and divide by the 7 first. So in this case, we have 7e to the 2x is equal to, so 20 minus the 5/2, if we want to write it as a fraction, gives us 35 over 2. And so remember, when you subtract fractions, you have to get a common denominator. So you're basically taking 40 over 2 minus 5 over 2, which is where we get the 35 over 2. And then divide this by 7. So e to the 2x is equal to, remember when you divide a fraction by a fraction, you keep change flip. So this is really 7 over 1. So when you multiply it, it becomes 1 over 7. So that's where we're going to get the 35 over 14. Now that we've isolated the exponential expression, the next step is to rewrite this in log or natural log form in this case, because it's base e. So the natural log of 35 over 14 is equal to the exponent to x. And then the last step would be divide by 2. So x is equal to the natural log of 35 over 14 divided by 2. Could you write this as log base e? Yes, it means the same thing, but generally we don't write it like that. So then in your calculator, the natural log of 35 divided by 14, and then, oops, I have an extra parentheses there, divide that answer by 2. So that's the exact answer, and the decimal approximation would be about 0.4581. So again, same idea for question 12. Isolate the exponential expression, already done. Rewrite it in natural log form. So natural log of 30 equals x plus 1. And then so x would be equal to the natural log of 30 minus that 1. And again, remember, you cannot subtract 30 from 1. 30 is in the argument of the natural log. So think about it like this. So we have the natural log of 30 and then minus the 1. So x is equal to 2.4012. So that would be the exact and the decimal approximation. So this is the exact and this is the decimal approximation. Over here, same idea, isolate the exponential expression. So e to the 2x over 3 is equal to, and 9.1 minus 7.2 gives us 1.9. And if you wanted to write that as a fraction, you can. So that would be 19 over 10. So e to the 2x over 3 equals 19 over 10. Rewrite this in natural log form. So the natural log of 19 over 10 is equal to 2x over 3. So then to get rid of the 2/3 x, you're multiplying both sides by 3 halves. So then this would give us x equals 3 times the natural log of 19 over 10 divided by 2. And so in the calculator, we have 3 natural log of 19 divided by 10, close those parentheses, divided by 2. So x is approximately 0.9628. Okay, and that is it for solving our exponential equations. And again, of course, remember to plug these values back in to check your solutions to make sure that they are correct. I'm just assuming that you guys can do that on your own.